This video is for topic 4 in the right triangle trig unit. Today we're going to be discussing SOHCAHTOA and finding ratios. First, before we do anything, we're going to have to label the parts of a right triangle. We know that angle B is my right angle. We also know that across from angle B is my hypotenuse, or my C, as we did in the Pythagorean theorem. So my hypotenuse is the side opposite the right angle. Now we have two other sides that we need to label, and that is our opposite side and our adjacent side. So in order to do that, we need to pick an angle. So for the purposes of this, I'm going to pick angle A. It's an acute angle. Once I pick it, the side opposite angle A is called the opposite. The only other side left is the adjacent side. The adjacent side is connected to angle A, but it's not the hypotenuse. So if I look at this example, I have three sides of a right angle, a right triangle, and they have a question mark right here, so I know I'm picking angle F. So I have a couple of ways I can do this. My hypotenuse I normally label first. With numbers, it's easier because it's the largest side, but it's also across from the right angle, so my hypotenuse would be 26. If I look at F, across from angle F is 10, or DE, for my opposite side. I have 2 out of 3 sides left. The last side is my adjacent. It's the one that is connected to F, FE, notice it has an F in it, but it's not the hypotenuse. So the adjacent in this case is 24. In order to solve any right triangle trig problem, you have to be able to correctly label the opposite, adjacent, and hypotenuse. Once we have that done, we are going to look at our trigonometric ratios. I'm going to use those same 3 words. You can see hypotenuse sitting here, and down here you can see an O and an A, probably stands for opposite and adjacent. So my sign, and I'm going to use these, remember this by, my sign is right here. O would stand for opposite. So I have my opposite over my hypotenuse. The other good thing to recognize is this helps me pick which angle I'm going to choose in my triangle. So cosine of B, cosine, has an A in it, so that's going to be my adjacent side. My tangent would be my opposite leg over my adjacent leg. So I remember this by SOHCAHTOA, and I like and prefer to use this one because it already kind of shows me that they're in fractions, and that's how I'm going to be using them. So once I know these ratios, you're going to have it memorized. We can move on to actually looking at a triangle. So before I get started, what I want to do is I want to label these opposite, adjacent, and hypotenuse. My hypotenuse is never going to change. It's always across from the right angle. So my hypotenuse is GF in both triangles. Now, I have to pick an angle. In this case, I'm picking F. Notice they also put F right here to show me that I was picking it. In the triangle on this side, I picked G. And it also showed me right here, sine of G, which angle I'm picking. So now that I've labeled my F, I'm going to label my opposite side. It's across from it. And my adjacent side. In this triangle, I'm also going to label my opposite side and my adjacent side. And they switched. These are the exact same triangle, and the opposite and adjacent switched based off of which angle I chose. So now that I've done that, it tells me, suppose GE is 5. From G to E is 5. in both triangles. EF is 12, EF is 12, 12, and finally GF, which is my hypotenuse, is 13. And if you remember right, 5, 12, 13, we had a special name for that, and that was a Pythagorean triple. So if I move back and I look at the problem, it says sine of f. Before I do any problem, I always use my SOHCAHTOA, which I'm writing up here, and I almost write this for every problem just so I have it. Sine is O over H, cosine is A over H, and tangent is O over A. And I'm going to fill that in on the other side as well. And that's for my reference, so I know what's going on, and it becomes a matching game. So in the triangle above, the O is 5, so a 5 goes right here. The H was 13. So my sine ratio is 5 over 13. The cosine of f is my A, or adjacent, which is 12, over hypotenuse, which is 13. And my tangent would be my opposite, which is 5, over my adjacent, which is 12. In this triangle, I'm going to look at the sine, cosine, and tangent of angle G. So I'm dealing with this half of the problem. So in this triangle, because G is the one I picked, my opposite is now 12, but my hypotenuse stays the same. In G, my adjacent is 5, and my hypotenuse, once again, is 13. And finally, my tangent, my adjacent and my opposite are used. It's going to be 12 over 5. So that's how you label the triangles.